Assalamu alaikum, students. Now we are beginning with the second part of forces and shape. And in the previous video, we discussed about the basics of Hooke's law, and we also studied other types of forces. So here we will have a brief overview on this elastic and plastic behavior. What does elastic behavior mean, and what does plastic behavior mean? Okay, so if a material returns to its original size and shape when you remove the forces stretching it, so we say that the material has the uh, elastic behavior. Okay, that behavior shows elasticity of the material. And if the material does not return to its original size or shape and it stays deformed, means it does not come back to this original length or shape, then we say that it is the plastic behavior, and the forces are greater than the elastic limit of that behavior, that material. So if we apply too big a force, a material will lose its elasticity. So every material has some maximum amount of force that can be tolerated by that material. So if we exceed that limit, so the plastic deformation will occur. Okay, so here Hooke's law, name of the scientist, and we already studied about it, that the amount of spring stretches is proportional to the amount of force applied to it. This means if you double the force, its extension will also double, and if you increase the force 3 times, extension will also be 3 times greater. So here the diagram is showing. Is shown unstretched spring. The force F causes extension of X, then 2F will cause extension of 2X. So force is doubled, extension is also doubled. So here some springs of different materials are shown. So here the spring constant K is 60 Newton per meter if the 60 Newton force will produce 1 meter extension. So what force will make the spring stretch a distance of 5 meter? Of course, the 5 times greater force. Okay, so 300 Newton force will stretch it by 5 meter. So there are like different materials have different elasticity, and their stiffness is also different, and value of K is also different. So value of K, the spring constant, that depends not only on the material, it also depends on the geometry of the material, how much longer or thicker the spring is. So here there is a question: which one will have greater spring constant, steel or aluminium? Okay, so usually steel is stiffer than aluminium. It has greater spring constant. Here there is an experiment shown, and which was discussed in the previous video also. The forces are gradually increased from 1 Newton to 6 Newton, and extension is produced, and the graph is plotted. So 1 Newton force is causing the extension of about 1 centimeter. Initial length, unstretched length, was already 1 centimeter, and 1 Newton force has stretched it up to 1 more centimeter, means total length has become 2 centimeter. Now let us see what happens when we increase the force. 2 Newton force, it's causing it to become 4 centimeter longer. Okay, so each 1 Newton force produces 2 centimeter extension, and 2 Newton force produces 4 centimeter extension. So 3 Newton force, 6 centimeter extension. So this is how the forces are increased and extension is also increased. So now this is 5 Newton is the elastic limit, because the graph is no more a straight line, it has become curved, means this is the last force which can be tolerated by this spring. And if we hang 6 Newton force, see the graph becomes like this, means this force has caused elastic limit, and if we increase more than that, it will be permanently deformed. So this is how the graph is plotted and how the things are hung. So force is proportional to extension, so this is Hooke's law. And here spring constant, force over extension. Remember, we can take extension on y-axis and force on x-axis as well, but taking force on y-axis and extension on x-axis gives you directly the spring constant, because K is equal to F over X. So taking F along y-axis and extension along x-axis gives you the spring constant. So the greater the gradient of the graph, the greater will be the spring constant. So here three graphs are shown. So the hardest spring, the one which is having more spring constant, is the first one. So we call it stiff spring. Okay, the second one is softer than first one, and this is even softer because smaller force is producing larger extension in this. So unit of spring constant is Newton per meter. Here, we are again comparing extension of two springs, spring A and spring B. Force is taken along y-axis and extension is taken along x-axis. Now we are checking the stiffness of the two springs. So we are checking which one is stiffer or which has greater spring constant. So we apply same force to both the springs, spring A and spring B. So this is the force which acts on, and how much extension this force produces in spring B. This much is the extension, and the value of, suppose this extension is xb. Okay, now the same force is applied on spring A, and it produces the extension of xa in that spring. So spring A stretches more for the same force, means it has greater extension, means it is softer. Okay, so stiffer spring has stretches more is the spring A, and stiffer one is the spring B. So stiffer spring has greater slope and larger K. Now there is an example to be solved. Spring is 0.38 meter long. This is already unstretched spring when no force is acting on the spring. When it is pulled by a force of 2 Newton, it stretches to 0.42 meter. Okay, so what is the spring constant? You have to calculate. So now the total length has become 0.42 meter. So initial length was 0.38. How much is the extension? You will subtract the new length from the unstretched length. So the answer comes 0.04 meter, means 4 centimeter, you can say. So 2 Newton force is causing that extension. So 2 is equal to K into 0.04. So spring constant is 50 Newton per meter. Okay, so stiffer spring will have even greater spring constant, may have 100 Newton per meter, 200 Newton per meter, like this. So here again another example, a force of 5 Newton causes spring to stretch by 0.15 meter. How far it will stretch if the force is 10 Newton? Of course the force is doubled, so extension will also double. And graph has not crossed the elastic limit. So here 5 Newton force, and it is producing extension of 0.1015 meter, means 1.5 centimeter. So now 10 Newton force, how much extension will it produce? It will be, it has to be calculated since the force is doubled and force is directly proportional to extension. Graph is a straight line, means you can simply double that extension. Double the force, so double the extension. So answer will be 0.03 meter. Okay, so slope is change in y-axis over change in x-axis. So f is equal to kx and k is equal to f over x. And that slope represents the spring constant. Now Hooke's law, the amount of spring stretches is proportional to the, now this is a key definition, and this is the diagram when the spring crosses the limit. Okay, so here it has become curved. Some summary of the Hooke's law and some new points. When a force is applied to an object, it may be able to stretch and change its shape. Any object which can go back to its original shape after the force has been removed is an elastic object. It means the force is within the elastic limit of that object. So when we stretch something by force, means work is done, and here that work appears in the form of elastic potential energy. The spring stores elastic potential energy in it. Okay, force does work and stretches the spring by distance x. So that is work done, F into x. So that work done is stored in the form of elastic potential energy. So when we pull this and release it, it will start vibrating, means that this will convert into kinetic energy. Here, student uses this. This is another way of studying Hooke's law and the elastic behavior. A student uses apparatus shown in figure to obtain extension load graph of a spring. Okay, so if the 10 Newton force produces extension of 2 centimeter, calculate the spring constant. So you will calculate the spring constant here, convert centimeter into meter, means 0.02 meter. So 10 divided by 0.02 will give you the spring constant of this spring. Okay, so this is the setup shown here. Now the student takes the second spring that is identical to the one in the figure above and hangs it next to the first spring. Now two springs in parallel and applies the same force of 10 Newton. So how much extension will be produced in this? Now here the extension which will be produced will be halved. Why this will be halved? Because the force will be shared by the two springs. So 10 Newton force means 5 Newton is supported by spring 1 and 5 Newton is supported by the another spring 2 which is connected in parallel to it. So 10 Newton stretches the spring by 2 centimeter, means 5 Newton will stretch both the springs by 1 centimeter. So extension now will be 1 centimeter. What does that mean? Here the springs shown in this. So the forces which will be acting on the two springs will be 5 Newton on this spring and 5 Newton upward on this spring. So 5 Newton, total 10 Newton. Okay, so this 10 Newton divides into two parts. So 5 here, 5 here. So this is 10. So 5 Newton will stretch each spring by 1. So total stretched length will be now 1 centimeter longer than before. Suppose this system was, say, without the force, suppose it was 10 centimeter already. Okay, without this unstretched. So this is unstretched length. So what will happen when this 10 Newton force is hung? So its length becomes 11 centimeter. Means this has produced, it will be 11 centimeter in total length and 1 centimeter longer than before. Okay, so this was about the springs in parallel. So in the same way, we can have the other way. This is unstretched spring, same spring, 10 Newton force, and it is producing 2 centimeter extension. How much extension will be produced when the springs are attached this way, one after the other? We call it series. These are the two identical springs and 10 Newton force is hung. So each, because 10 Newton is acting on both of them, so each spring will extend by 2 centimeter. So total extension will be 4 centimeter. Okay, so it means when we connect two springs this way, extension will increase. But when we connect the other way around, this way, parallel, extension will be less. Means the system is more stiffer than the system in this. Okay, in the same way, we can stretch the spring horizontally also. Like this is horizontal spring and we apply the force, there will be extension produced in the spring. And when we apply compression force, it will become shorter. In both the cases, energy will be stored. Okay, in the first case, it will extend, it will become longer than its initial length. And here in the second case, it will become shorter than its initial length. And F is equal to kx. This law is applied to this case as well. Okay, so more force will produce more extension or compression. So That's all for today. And watch the video carefully and ask the question if you have any doubt related to it. Allah Hafiz.